Here is the Daily FM summary of the Latent Space that aired on Monday, August 3rd. This episode was a deep technical masterclass on inference engineering with Philip Kiely and Ali Taha from Baseten, joining Swyx and Vibhu to explain what actually happens after an open model is released and before users experience it as a fast, reliable API. The opening question was simple but revealing. What happens when someone sends a 200,000 token prompt? Philip explained that the system first asks whether part of that input has been seen before. If so, cache-aware routing can send the request to a machine that already has some KV cache, avoiding expensive recomputation. If not, the system may split the work between pre-filled GPUs, which process the giant input and generate the first token, and decode GPUs, which produce the output tokens. For coding workloads, Baseten may also use speculative decoding, where a smaller model guesses several tokens ahead and the large model verifies them. That led into the distinction between shared paper token APIs and dedicated deployments. Ali said dedicated deployments become attractive when traffic is high or specialized because customers can tune batch sizes, quantization levels, routing, and even train a custom speculative decoder for their own traffic. Philip added that dedicated endpoints also avoid noisy neighbor problems, like someone else benchmarking a shared API with massive traffic. A major theme was that supporting a new open model is much more than making it emit one token. Philip said open source engines like VLLM or SGLang may get basic support quickly, but production readiness requires quantization, calibration, training speculators, testing, routing, and handling new architectural quirks. Ali and Philip gave a striking example from GLM 5.2. Baseten grafted Kiely's vision encoder onto GLM without changing the language model weights, training only the projector between the eyes and the brain. Ali said the model learned much better when trained not just to caption images, but to answer detailed questions about them. One of the most surprising sections was on failure modes. Models can collapse into repeating the same token, sometimes not because the weights are bad, but because of inference engine bugs, queue-to-kernel race conditions, or differences between clusters and network interconnects. Ali described cases where the same model behaved differently depending on hardware and KV cache transfer timing. The discussion on quantization was especially important. Philip framed quality as fidelity to the original full precision model. Ali explained that quantization is lossy, but Baseten found that quantizing more layers can sometimes preserve quality better because errors in different layers cancel each other out. They measure this with KL divergence between logit distributions, not just benchmarks, and claimed this can improve throughput by around 20% while maintaining fidelity. The broader takeaway was that inference is still young. Philip said mature fields fight for basis points, while inference optimizations still deliver 20%, 100%, or 200% gains. Stacking NVFP4 quantization, speculative decoding, disaggregated prefill/decode, better kernels, and cache-aware routing can move a model from tens of tokens per second towards several hundred, though the exact gains depend heavily on hardware and traffic. The conversation then widened to NVIDIA Dynamo, model parallelism, megakernels, Rubin, and AI chips. Philip sees Rubin pushing inference towards systems engineering, moving KV cache around clusters, coordinating GPUs, CPUs, and networks, and designing around memory bandwidth. Ali was notably skeptical of megakernels, arguing that future GPUs are becoming more specialized and that many fused kernel approaches may not survive in production. They also covered video generation, where Ali said open source video still lags far behind closed models like Veo and Kling. The blocker is attention over enormous numbers of video tokens. 5 seconds can already mean tens of thousands of tokens, and long videos become brutally expensive. Autoregressive video could enable streaming and longer generation, but today's quality is poor, while diffusion gives better consistency but struggles to scale to long coherent sequences. The episode closed by tying inference back into training. Faster inference helps reinforcement learning rollouts, while training increasingly has to account for quantization and speculative decoding. Philip predicted continuous loops where deployed models generate traces, get post-trained, A/B tested, and redeployed. Ali gave the memorable example of GLM 5.2 helping profile and write kernels for serving GLM 5.2 itself. The final frontier, they suggested, may be continual learning through persistent KV cache, compacted memory, and models that help optimize the infrastructure they run on. Thank you for listening to Latent Space in 3 minutes from the Daily FM. See you next time.